All right. Today we're going to look at the third method of solving these equations, and that's solving systems of equations by elimination. Wink face. Elimination is the student's favorite method of solving. Favorite.
Seriously?
Mm-hmm.
100%.
No, they just tell me. Trust me, you'll see it. But before I look at it here, go ahead and write these equations. And yes, you have J and S. J and S. And you're like, what? Yes, you can. And listen, for the other class, I didn't give them homework, but that's because they were already in class. So if you guys stay with the class, there's no homework tonight. That is up to you, personally, individually. Okay. Write these down, and yeah, you have J and S. When you have variables that are not X and Y, just think of them in alphabetical order, which in the ordered pair, X comes before Y, correct? So which one in the ordered pair for J and S would come first? J, then S. Alphabetically, J comes before S. So hopefully you're not too confused by that. Once you write this down, I want to look at the bottom equation. What I'm going to do could have been done to the top equation, but I just picked the bottom one because sometimes it makes more sense to look at that one. Okay. 2j minus 2s equals 26. That's an equation. Do you guys remember what an equation is?
Yes.
Do you remember me standing up here as a balance beam? And do you remember what an equation has to do? Has to stay balanced or equal, right? It has to be balanced. Okay, up here I have my 4 balance beams because I'm going to write something up here on each one of them. According to that bottom equation, isn't 2j minus 2s balanced with 26? Is that what it's saying down there, that second equation? Yes or no?
Yes.
Yes. Okay. So these two are equally balanced. They are equal, and therefore I can switch them around. So am I allowed on the second balance beam to put 26 and 2j minus 2s? Am I allowed to do that?
Yes.
Yes, no, maybe so. Okay. Yes, because all I did is I moved the two weights, switched them over, and we still have a balanced equation. Great. These next two they're going to be kind of weird because you're like, why is he putting that up there? But I'm going to try to link that up. Am I allowed to say that 26 is balanced with 26?
Yes.
Okay, hopefully that makes the most sense. They're the same number, they balance each other out. But am I also allowed to say that 2j minus 2s and 2j minus 2s are balanced? Using those 4 scales, I'm going to be able to show why we're allowed to use this new method here. Okay? So I'm going to keep referencing these scales because I'm going to say, are you allowed to do this? You're going to say, well, yeah, because they're equal. Are you sure they're equal? Yep. You really think they're equal? Uh-huh. Were they really equal? Yes, they were. Okay, ready? When you have an equation, are you allowed to add the same thing to both sides? Are you allowed to add the same thing to both sides and keep it balanced?
Yes.
That's the addition property of equality. Are you allowed to subtract the same thing from both sides and keep it balanced?
Yes.
Yes, we're going to look at those properties today in this lesson. Ready? I have this top equation, which we really haven't talked about, but isn't 1j plus 2s equal to 49? So these are balanced too. These are balanced. Okay, I'm going to do this. I'm going to add both of those equations together. It's kind of strange, but let me show you why. Look at the top equation. You see the two sides here? When I add 2j minus 2s to the left side and 26 to the right side, am I keeping the top equation balanced? That's a deep question here. Look at my... Someone explain how I'm keeping it balanced. Because they don't look balanced when I do it. What do you think, Chelsea?
Well, I don't know if they look because aren't you adding like different numbers?
They look different, don't they? But are they different according to this balance? So I added 2j minus 2s to the left side, and I added 26 to the right side. So did I add the same thing to both sides? I did. I'm allowed to do that. It just looks weird, doesn't it? But watch what happens when I do that. Yes, ma'am.
Wait, can it be balanced because you're adding the same variable to the same number?
Okay, that's like terms, and we're going to look at that. But I'm just talking about the whole thing being added to here, and this whole thing being added to here. Like, did I keep it balanced? Yes, ma'am?
But wouldn't you only just get one variable?
Wait. Yes, Jack?
So now you add in the bottom part to the top part, and then you like put them on both sides.
Yeah. And I'm allowed to do that, right?
Yes.
If it keeps it equal. Cole?
You're saying that they're like, so 1j plus 2s is equal or the same as 49.
Exactly. They're equal.
So
Mhm.
you add it to both sides, just adding.
You're just adding the same thing to both sides, even though it looks different, right? 26 and this are the same? Yeah, they are. They're equal. Watch. What's 1j plus 2j? 3j. What's 2s plus negative 2s? 0s. You know what happened to those variables? You know why we get this name? They got eliminated.
Oh no.
They're eliminated. They're gone. What's 49 plus 26? 75. Look at my equation now. Can you guys solve 3j equals 75?
Yes.
What do you do to both sides? J equals. So I have an ordered pair. J should go in the first spot or the second spot?
First, second, first.
First, because it's before us.
Yeah, J comes before us. So 25 goes up there.
So could you use any variable?
You can't, they're going to use any variable.
A and Z.
Yep. You use A and B, C and D, C and D, C E, C sub E,
What
C
if you
sub
have
D.
like A, B, and C?
That's later. Don't get ahead of us. Okay. Yeah. How do I get S now? Why do you think I do it? Think of our last method. Solving systems of equations by substitution. So instead of 25 instead of J, what am I going to put? For which one of these?
Doesn't matter.
Doesn't matter. The top one's fine. Instead of J, I'm going to put 25. Ready? 1 times 25 plus 2s equals 49. So I substituted. Notice how we're using substitution for elimination? Because you need to understand substitution. All right, yes. What's 1 times 25?
25.
All right, 25 plus 2s equals 49.
Subtract 25 from the side.
Subtract 25 from both sides. You get 2s equals 24. Divide both sides by 2. You get s equals 12. Solution is... Do you remember what I said about elimination? It was the student's favorite, and how many of you doubted?
I did. None of us.
You. The people, not everyone, but the people who are saying, I don't think that's true, are now saying they like it.
Something that's not true before. Yeah, that is true.
Wait, what's true? The not being true or the true being true?
Hard, but like I go home and do the homework and then get all of them.
No, and the thing is, listen, hard is not, it's not like this means hard. Like for me, this is hard. For you, this is really hard. But some of you think that's really easy. Hard is a subjective term. I can't say it's easy or hard. It's hard for me or it's easy for me, but it's different for you. Yep.
So with the elimination thing, you had 2s and then negative 2s. But what if you had negative 3s and you were left with 2 variables?
Okay, great question. Then elimination would be a bad way to go. So I'm going to show you here, and actually you're already answering a question I'm going to answer later, but it's saying, does elimination always work? No. Can I make it always work? Yes. So in that case, no, that didn't work, but there are things I could do to make it work. That's later. Okay, let's look at another one. Oh, by the way, do you know what this answer means? If I were to graph these two lines, that's not a line. Can you think of that as x and y, x and y?
Yes.
Can you graph that technically then?
Yes.
So you got these two lines, and where do they intersect?
25, 12.
Yep, that's where they intersect. That's the solution to both of them at the same time. We're still talking about the same thing as the first lesson in this chapter. Okay, let's look at this one right here.
Why do you teach us the easiest stuff like after?
Here's why it's easy. Because you went through graphing, now you know that you get points where things meet up. So you get that now. For substitution, you're like, okay, I can substitute this value for that value, so now I understand x can equal that, substitute it. Now for elimination, you know why it's so easy? Because you understand graphing and substitution way better. This is not easy when I first teach it. If I just taught it like elimination, you're like, what? Like, what is this? Like, what? Wait, what is my answer? No, you get it because you know the other two. So that's why it's easy. Yep.
Does it matter if you add or subtract?
No. Because remember, are you allowed to add to both sides the same thing? Yep. Are you allowed to subtract the same thing for both sides? Yes. But one of them's better than the other. Let's see which one works on this one. Do you want to add the two equations or subtract the two equations? I want to add. You're like, why would I add? What's 3r plus negative 2r? 1r? Okay, or just r. What's 2s plus negative 2s? They get eliminated. We're done with the s's in this portion of the problem. And then here's a little bit tough, but what's negative 1/2 plus 1/6? What's negative 1/2 plus 1/6? If you don't get how to do that, here's the process, because this is kind of review. You get negative 3/6 plus 1/6, which equals negative 2/6, which equals negative 1/3. That's what you get for r, negative 1/3. And what is 1 times r? Yeah, so you can just drop that out. You got r, it's negative 1/3. And you didn't have to go through that process, but if you did, fine. Which one comes first, R or S?
R.
R comes first. How do I find S? Ma'am?
You multiply negative 1/3 by either negative 2r or 3r.
So what's that? What do we call that when I'm replacing something with something?
Substitution.
You're going to substitute negative 1/3 for this r or that r. Yeah, which one do you want? Your choice.
3R.
Okay, I heard the second one just barely before that 3r, so I'm going to go on the bottom one. Either one works. Negative 2 times negative 1/3 minus 2s equals 1/6. Was there an easier way to do it?
Yes.
Yes. Did you know that necessarily? That's okay. And you may go through the hard way every time until you start realizing, I always get fractions. I hate fractions. But if you went the other way, that eliminates the fractions. Okay, but what's negative 2 times negative 1/3? Positive 2/3 minus 2s equals 1/6. What do I do to both sides? Subtract 2/3 from both sides. This is where people get stuck. Negative 2s equals, do I have a common denominator? No. Can I make negative 2/3 into negative 4/6? What's 1/6 minus 4/6? Negative 1/2. It becomes negative 3/6, which is negative 1/2. And then, I want to hear you guys. What would you do here? Divide by negative 2 is a way you could do it. Multiply by the reciprocal of negative 2 over 1. Multiple both sides by negative, not negative, just negative. By negative 1/2. Because what happens here? What's a negative times a negative? What happens to all those numbers? They become 1. So I get S equals a big fat 1/4. That's your answer. Do you guys kind of get that?
No.
That's a hard problem, by the way, because of the fraction. It's okay. Guess what? We get to practice. You know how many times you're going to practice? 6 more times.
I'm not going to, like, if you had put, like, r equals 1/3 to you the problem?
Yes. This one would have been easier. But both of them work. Because substitution means r is equal to this, so it should fit here and here. It works in both. Okay, ready? Let's do it again. If you can do it on your own, go ahead and do it. I'm going to add these two equations together. You know why I'm going to add them together? Because when I do that, something gets eliminated. You ruined my emphasis there. No. I'm going to add. All right. Yes, ma'am?
Why don't you put a bracket on the other side?
When you put a bracket or a brace on both sides, you're talking about a set in math. When you put a brace on one side, you're talking about a system. So it's a technical way of saying a system.
So it would mess the problem up.
Yeah, it's a different problem. It becomes something else, which is not what we want.
Are all the problems gonna have like plus 3b or like negative 3b, like the same number on top and bottom?
Today they will. Tomorrow, sorry. Okay, what's 5a plus 7a? 12a, good. What's 3b plus negative 3b? That got eliminated. What's 113 plus 7? 120. How do I solve for a? 5 by 12, I get a equals 10. What should come first, a or b? Thank you. A. So that's 10. How do you get the b? Sophie knows. Elizabeth knows. Chelsea knows. Emily, what do you do? Substitute 10.
For A.
Which a? For which a?
It doesn't matter.
Which do you pick? Top? Fine. You could do either one, so we're going to do top. What's 5 times 10? Plus 3b equals 113. Can you solve for b? Now, when you work out this problem, you get b, and now you have a and b. How do you know your answer is right?
You can check it.
Where does it have to check?
In the original problem.
Both original equations. Yeah, the original problem. So who can give me what b is? Cole? 21. Any questions on that, how he got 21?
You subtract 50 from 113.
From both sides, you get 3b equals 63. And then divide both sides by 3, you get 21 equals b. Okay, great. Let's see if it works. What's 5 times 10?
50.
What's 3 times 21?
63.
What's 50 plus 63?
113.
That checks, right? Does it also have to check here?
Yes.
Can I give you a little word of caution? If it checks on the top, does it always check on the bottom?
No.
No. In that last class, someone got, Mr. A, I got these two answers and it checked. I'm like, oh, really? We looked at the first one. Yep, it sure did check. What happened on the second one?
It didn't check.
Didn't check. In fact, they got so close, but they just did the addition wrong, and that's why it worked. But it wasn't supposed to work because the addition was done incorrectly. 7 times 10. 70. Negative 3 times 21. Negative 63. 70 minus 63. Checks. It checks for both. It has to be the solution. That's the answer. You like elimination?
Can there be more than one solution?
No, one solution. On these, you're going to get one. Technically, you're allowed to get an infinite number of solutions or no solutions. Not yet.
Like on the infinitely many one?
It's going to come out like a special equation. Something's going to happen. You get stuck, and then you look at the equation and say, wait, that's infinitely many. Or you get stuck and you say, wait, that's no solution. But that's not yet. I'm not giving those. Those are called...
Confusing part.
No, they're just called exceptions. Exceptions, like parallel lines, same line. Okay. Can you only add to both sides? Is that all you can do to both sides of an equation?
No, fractions like it doesn't.
Yeah. And I'm going to extend that. Are you only allowed to add both sides by something or subtract both sides by something? No. You're also allowed to multiply both sides by something and divide by it. But that's tomorrow. Today, I need you to write this down.
Oh, we need to.
Excuse me?
We need to divide on this one so then the 2.5 can cross out.
Write them down. Let me go through my thought process to see how you would figure out what to do here. What have we done so far to both equations? Every problem this afternoon. We've added. Okay, now watch what happens. You don't have to write this next step down. I'm going to write it, but look at the board when I'm doing it. I'm going to add, right? I think, wait, we're just going to add. What's 2.5W plus 2.5W? 5W. What's 5b plus 2b? 7b. And 55 plus 28? 83. Did anything get eliminated? Did that help me then? No, that was not the right thing to do. Oh, sorry. Oops. What did I say though? That's okay. You can just rewrite again if you really want to see. All right. Instead of adding, I'm going to subtract both equations. Ready? What's 2.5w minus 2.5w? Good. They got eliminated. They're done. W's are done. What's 5b minus 2b?
3b.
No b. No, sorry. Oh, man. No. No, there's something. I'm going to say it later. I'm sorry. What's 55 minus 28? 27. Good. 27. So did something get eliminated?
Yes.
Yep. Is that good?
Yes.
Yeah, because all I have to do now is do what to both sides? Divide by 3. I get b equals 9. So what comes first, B or W in the alphabet?
B.
B. So that's 9. Yes, ma'am?
I have a question. So when you put 9 in one of the things, do you want us to make it the decimal
Okay,
a whole number?
you can, but you don't have to. It works either way.
So you can.
You can, you don't have to. Yeah, some of you, like, you are repulsed by decimals. You utterly hate them, and you will do that. And some of you are like, decimals, we got off to a bad start. Let's try to work this out. And you work it out.
But if you did, you'd have
Yep.
to change everything.
Everything. So it'd be 25W
20.
plus 20B equals 280. So yeah, we don't want to do that. In this case, which one do you want to put B into? The top B or the bottom B?
Bottom.
What do we call it when I take this 9 and put it in for those B's? Substitution. So do you remember you have to understand substitution in order to get elimination? Because you can get this far and you're like, great, but what do I do next? Substitute. Which one, sorry, top or bottom?
Bottom.
I heard bottom. 2.5W plus 2 times 9 equals 28. So I substituted 9 for B in the bottom equation. Yes?
For decimals, do you always have to subtract?
No. It could be adding or subtracting. It just depends. What's going to get it eliminated? In this case, adding didn't eliminate it, so subtracting would have eliminated it. But you don't have to do one or the other every time. All right. 2.5W plus 18 equals 28. How do we solve that? Sydney, help me. That's okay.
You subtract 18.
Okay. Josie, what do I do next? I get 2.5W equals 10.
Divide both sides by 2.
Oh, sorry about that. What's 10 divided by 2.5?
4.
W equals 4. Yeah, stay quiet, guys. Remember what I said?
Quiet.
Maybe you didn't. I'll give you a sad reminder, unfortunately, if you don't remember. Okay. Do you guys get 9 and 4?
Yeah.
Does it work?
You have to check it.
It does work.
What's 2.5 times 9 or 4?
4.
4. 10. 5 times 9?
45.
45 plus 10? Check. 2.5 times 4? 2 times 9?
18.
18 plus 10? Checks. Has to be it. You get how it has to be it? Like it's not like, kind of. No, it must be it. Your turn. Nice. I am too, trust me. This is my 6th class teaching.
This is my 7th.
Technically, you would only have 4 if you didn't give us 2 math classes.
Yes, but I want. That's true.
Mr. A, how's it feel sitting there trying to grade when teachers teach expand?
Bounded.
I learned too much about you guys during that class. Some things are good, and some things ... Okay. How many of you are going to add these two equations?
Me.
But you don't know. It doesn't know.
What's x plus 3x? 4x, right? What's negative y plus negative y? Negative 2y. 5 plus 7 is 12. Does that eliminate anything? So I'm not going to add, I'm going to subtract. Now this is where you got to be careful, please. If you're like, what are you doing? X minus 3x is negative 2x. Negative y minus negative y is the same thing as negative y plus y. What's negative y plus y? Eliminated. 5 minus 7, negative 2. Okay, so that's enough help. Aren't the signs critical? I heard one yes. I saw 2 nods. Yes, they are critical. Since 7th grade, I've been telling you, those signs are important. And still, 7th graders today will say, doesn't matter. Teach them, guys. Tell them. The signs matter. Signs matter a lot. In many, many applications. Yes, ma'am?
Can we teach the 7th graders a lesson?
And
You may.
We should let Max do it.
Seriously?
No, yeah, it's up to you. Go do it. I'm not going to hold you back.
the best for the situation.
Break, lunch, before, after school. Your choice. Weekend. It wouldn't work, Elizabeth, too much because you have class when they have class and they have class when you have
I'm
class.
sure you can get them to. I mean, Miss Burrow was able to do that for Veterans Day, so I'm sure you can.
What is y?
One.
What's y?
Negative 6. It's negative 4.
It's 3.
Uh-oh. Can't be both or all three of those.
Negative 4. Negative 4.
So you see how I substitute 1 for x in the top equation?
Yes.
Negative 4.
It's 4, and then you divide it by negative 1, and then you get negative 4.
Told you.
Did you get that? Yes. Okay, and did you get how to get the other one? That's tough. How many of you got something other than negative 4?
No.
Did it check? Check that next time and see. You're like, ooh, that's not it. And then you can figure it out. Okay. I think it's time for, let me see my next problem. This next problem, I want you to realize that how many methods have we learned to solve systems of equations?
3.
Graphing, substitution, elimination. Which one's the best? It's up to you. Which one do students like the most?
Elimination.
Depends. No, it's elimination. You tend to like elimination. I'm fine with that. But is elimination always the best?
Yeah.
Your choice. Yeah, but be careful when you actually get that final number. 3a minus negative 4a, right?
Did you subtract?
You tell me.
Subtract.
Why?
Because you can't add 2b plus 2b because that would be 4b.
Okay. So subtract. I asked you that. If you add, you're going to get negative 1a plus 4b equals 7. Is that what you wanted? If you subtract, you're going to get, what's 3a minus negative 4a? 7a. What's 2b minus 2b? Not to be. Okay. I accidentally said that in the other class. So what's 2b plus or minus 2b not to be? One person snickered. Do you see? Okay. Snickered. Not even laughed. Just kind of. I was proud of that one. Wait, what? Sorry?
It doesn't go in.
What, this?
Yeah, no, it does. But then when you substitute it does it.
That's okay. It's okay. Because it was 0, minus 7, negative 7. Be careful with that.
How did you get that? 'Cause when I subtracted 3 from negative 4 and I got 1.
Okay, that's 3a minus 4a would have been negative 1a, but it's 3a minus negative 4a. I know that's tough. I get that. But a is negative 1. Don't be scared of b, but b is not even. In fact, most of life is not even. Deal with it. So what do you get for b?
3 over 2.
3 over 2. You got me. I know you got it to
1.5 or 1.5? Either one is good. Okay, listen up. How many of you were able to see that a equals negative 1? Once you get to that point, you're substituting. How many of you substituted into the top equation? How many substituted into the bottom equation? I'm going to do the bottom equation. Negative 4 times negative 1 plus 2b equals 7. Okay, so I substituted a with negative 1. What's negative 4 times negative 1? Positive 4. What do I do to both sides? Subtract 4 from both sides. I get 2b is equal to 3. Divide both sides by 2, I get 3 halves. So that's how I got, or 1.5 or 1.5. I'm good with that. Okay, now what I'm going to do is I need 15 of you to get it right.
Ooh, I can do that, Mr. A.
Well, I hope you can. Not much room for error. 3 minutes.
3.
Starting 2 seconds ago. Go. Sorry, man, I meant 10 seconds ago.
How many R's in this class?
You called me Matt.
18.
Oh, I think I meant Max. Did I call you Max or Matt?
I think you said
I
Matt.
don't know. Max. Okay, when you get it and you want me to check it, I will, but I will not check it again. So either it's right the first time or not.
Can you tell us what problem you got right?
I can say X or Y, and then you can fix it. But you don't count anymore for this problem here. Are you done? Ready? Okay. Let's see what we're at. Put it in the order pair. Yes. 1, 2, 3, 4, 5, 6, 7. The Y. X and Y. You're doing this. You subtracted, so you get 2x equals 62. It's not 44. Oh, I didn't add. Or you didn't subtract it. I don't know where I'm at. What number? 6, 7? 7, 8, 9, 10. I gave an extra 10. 11. 12. 13. 2 more. I think I got him. 14. Ooh. 15. You reached your, did you get it? 917? Yeah, so 15. Yeah, 15, you got it. 917. How many of you are really thinking that elimination is always good?
Oh, yeah.
No,
Trick.
Me, I'm raising my hand.
Don't raise your hand.
No.
All of you need to get this right.
Yeah.
No, you work it out yourselves. I'm not helping. You have 3 methods to solve it. Elimination, substitution, or graphic. Don't do graphic.
Forgot how to graph.
That's okay. Don't graph it. It's hard. But can you do substitution? Of course you can. And which variable is the easiest one? I don't know. Or can you eliminate? Wait. Huh.
Can you divide by number or divide on the bottom? Because could you divide by 2?
Oh, you're asking me?
Yeah.
You're expecting an answer?
No.
Thank you. Thank you, Sarah. I was going to drag that on, but thank you. You ended that. Yeah, you can do whatever is using any of those properties or methods, and I hope you do well.
Can we ask Siri?
You can.
I don't have a phone.
I'm going to tell you this right now. You could use substitution, or you could use elimination. Either one. If you know how to do the substitution, that's going to be easy. But if you can't get there, like to that first step, don't do it. Substitution is easier. If you're going to use substitution, the bottom X is the best way to go.
Me too.
Uh-oh.
I mean, I'm going to do substitution because I don't know.
Yeah, I would do substitution too if you're not. I haven't taught you this elimination method. Some of you are getting it intuitively, which is awesome, but you don't have to.
I'm going to divide everything. Guys, I'm going to get it wrong. I'm warning everybody right now. So,
Solve for the bottom X.
actually, no. I'm looking at one.
And listen to me carefully. You went through a method, you hope you get it right, you get these answers, and you check them, and then you can tell me yes or no, you got it right. It's that's straightforward. The solution consists of 2 integers that are both positive. Mr. is being kind of nice now. Positive. Uh-oh. So I'm helping you out. 1. 2. All of you have to get it right. So I think there's 20 of you, except is anyone missing? Nope. 20. Sorry? No, you get 1 chance.
So if one of us screws up,
3.
mine will
Yes,
do it.
yes, that's exactly it.
Thank you. Putting a lot of pressure.
I'll have to edit that part out.
Oh, Mr.
No. What time is this class?
I don't know.
Sure.
I want to make sure. Okay, I'm ready.
Ordered pair. Sorry, what's that number? Oh, I think we're at 4 or 4. Thank you, 4. So everyone's gotten it right. Who's shown it to me? possible. What's the question?
Did I do this right?
Oh, you know your distribution? You know how you got negative 10?
Mm-hmm.
It's negative 10x. Are you done?
No.
Okay. No.
Yep. I got it wrong, so you can just go ahead.
Try it again then, if you know you got it wrong.
I don't know.
It's not the answer, I just have a question.
Okay, yep. Go ahead.
If we're substituting for a number, like for the letter, you just take out that letter, right? Like,
Yeah, like if you're substituting for x, like x equals 3, or sorry, x equals 2y plus 5.
is that what x equals?
No, I'm making that up, and if it is, that's just me making it up. Oh, wow, okay.
But then you don't put like another x at the end, right?
You don't put the x in, the x is gone, because you substitute for x.
I probably got it wrong because I didn't have much space.
You have plenty of space.
I'm the same number as I like to have pages.
6.
Oh, I got it! Substitution.
Are you good?
Yes.
Where?
There. I know.
Did it check? Or did you not check the check? I would check the check. Sorry. No. Sorry.
I'm not telling anyone. I promise.
No, I'm not saying you're telling them.
They asked me what I did, and I said nonsense.
All right, we got 2 more here. Sorry, hold on. I forgot what my answer was. Okay. All these numbers are, yes, 7, 8, 9. All right, listen carefully. I'm going to give you a little bit of a little push to help you out. I'm going to solve for x down here. So what I do is I'm going to subtract 6y from both sides. Yeah, stay quiet, guys, because everyone has to get it right. 2x equals, that canceled out, 60 minus 6y. And then what do I do to both sides? Divide everything by 2. I get x equals 30 minus 3y. And you can have negative 3y plus 30. It's the same thing. So I got this for x. What do I do with that x? Substitute it into the other equation for x. So this is the last thing I'm going to give you if you need it. And the rest is up to you. Did anyone do elimination? Elimination on this one. We're doing substitution. Most of us did. What'd you do? Yes, I did. Yep.
I multiplied the top one by 2, each number by 2. And then yeah.
Are you allowed to multiply both sides by the same number? So did you get 10x plus 6y equals 84?
Yeah.
And then you subtracted? Then you got eliminated, you eliminated the y's? Then you were left with 8x equals something?
Oh, wait. Mr. Right.
Yes, ma'am.
Wouldn't you have to multiply 6 by 2 as well?
She multiplied the top equation by 2, 2, and 2. You're allowed to do that. But that doesn't mean you have to multiply the bottom one. Yeah, you could just do it to 1. Sorry. Did you have it, Elizabeth?
Oh, I just am on the right track.
Gotcha.
Almost done.
Oh, I forgot to tell you your prize. I'm so sorry. That's probably important. When everyone gets it right, no one gets homework.
Thanks for counting on you, Max.
Wait, Mr. So, what happens if someone gets it wrong? I guess you can't turn it around.
All right, let me give you the answer for y. Who got y? Who got y?
I got one.
What's y?
It's 9.
9. Y equals 9. What's x?
3.
All right, but I feel nice. Go.